In this section we're going to solve a few more quadratic equations, and some of them will come out to have complex numbers as solutions. We may use this quadratic formula, so I put it back up here on the board. Let's go to the board first and take a couple of square roots of negative numbers and simplify them in terms of the number I, and then we'll get on to solving some equations. Suppose that I have the square root of negative 49. What I'm going to do is think of this as the square root of 49 times negative 1. I'll divide it up that way, then I'll have square root 49, square root negative 1, and that will give me square root 49 is 7, and square root negative 1 is I by definition. So that's how I'm going to handle square roots of negative numbers from now on. I really haven't done too much. It's just that I take that negative 1 that's under the radical and I am able to remove it outside by writing it as the number I. Once it's as the number I, then I can apply all the algebra in that I know about complex numbers from the previous section: add, subtract, multiply, and divide. Let's try one more. Square root negative 8. Square root negative 8 is going to be the square root of 8 times negative 1, which is the square root of 8 times the square root of negative 1. Square root of 8 is 2, square root 2. Square root of negative 1 is I. And just to be sure that I don't mistake this I for being under this square root, I'm going to write this usually this way: 2I square root 2. Now that's because multiplication is commutative even when there's the number I involved, and so I can change the order of this product, 2 times square root 2 times I, into any order I want. This is just a little clearer this way, and I won't make the mistake of thinking that that I is under that square root. Now what we want to do is solve a variety of quadratic equations, and we want to do it in such a way that we use the most appropriate method for the equation that we're trying to solve. Problem number 1, 2x squared plus 5x equals 12. Want to solve this quadratic equation? Well, whether I use the quadratic formula or whether I factor this, if it's factorable, I'm going to need to put it in standard form. So that's always my first step. 2x squared plus 5x minus 12 equals 0. Now I'm just going to try real quick to see if by chance this factors. If it does, that will be the quickest method. So let's try 2x and x, and then how about, what do I think, 3 and 4. Inside is 3x, outside is 8x. They differ by 5x. So I'll make the 8x positive and the 3x negative. Now did I do that right? 2x times x, 2x squared. Negative 3 times positive 4, negative 12. Inside I have negative 3x, outside I have positive 8x, they add up to 5x. So I'll set my first factor equal to 0, and my second factor equal to 0, by that zero factor property, which says that you can't multiply and get 0 without multiplying by 0. To solve this, I add 3 to both sides, then I divide by 2. That gives me x equals 3 halves. To solve this, I add negative 4 to both sides, and I get x equal negative 4. So I get two solutions here, x equal 3 halves and x equal negative 4, and this equation is solvable most easily by factoring because it's factorable. So if your equation is factorable, that's still the easiest method, so I would do that. Let's look at our next problem. Well, here we have one where I have that special form that I had at the beginning of the chapter where I had the square of a binomial equal to a number. So I'm going to take that method that says that if the square of x plus 1/2 is equal to this number, then x plus 1/2 itself is plus or minus the square root of that negative 9/4. So I'm going to use this little special method on this special looking equation right here to get down to this point real quickly. Now let's see, this is plus or minus square root of, I'm going to separate this into two separate radicals. No, I won't. This is a perfect square. Square root of 9/4 is 3 halves, and I'll take care of that negative sign under the radical with an I. Now I'll add negative 1/2 to both sides. X is equal to negative 1/2 plus or minus 3 halves I. So you can see I get two solutions, both of which are complex. X is equal to negative 1/2 plus 3 halves I, and x is equal to negative 1/2 minus 3 halves I. So two solutions, both of which are complex numbers. Now, this equation right here, I could multiply all of this out, put it in standard form by adding negative 9/4 to both sides, and then use the quadratic formula. But if I notice that it has this form where I can apply that theorem from section, whatever that previous section was, I'll do that because the solution comes out much quicker. Also, you notice by these solutions that this would never be factorable even if I did multiply it out, so I would have to use the quadratic formula. Let's look at another problem. 1/2 x squared plus 1/3 x plus 1/6. Well, no matter what method I use to solve this, I'm going to start by clearing this equation of fractions. So I'm going to multiply both sides of the equation by the number 6. That will clear it of fractions. So 6 times 1/2 times x squared is 3x squared. 6 times 1/3 times x is 2x. And then 6 times 1/6 is 1. Now here's the nice thing about standard form. When I multiply 0 times 6, I still get 0. So an equation that's in standard form to begin with, when you do this multiplication to both sides, it stays in standard form, which is kind of nice. Now let's see. I can try to factor this, but no matter how hard I try, this thing is not going to factor, which means I need to use the quadratic formula. So a is equal to 3, b is equal to 2, and c is equal to 1. So I identify a, b, and c in order to use the quadratic formula. And by the way, even if this did factor and I happen to not be able to factor it myself for some reason, still applying the quadratic formula always works. So even if by chance something does factor and you don't notice that it does, and you apply the quadratic formula, you're still going to get the right answer. It's just that it may take a little longer using the quadratic formula than it would if you factored like on that first problem we looked at. Okay, so I'll substitute into the quadratic formula. X is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So identify a, b, and c, substitute them into the quadratic formula exactly the way the quadratic formula is written. Now the rest is just simplification. So let's see what we get. Let's see, 4 times 3 is 12, times 1 is still 12, so I have 4 subtract 12, that's going to be negative 8, and that will give me some complex solutions. That's all divided by 2 times 3, which is 6. So negative 2 plus or minus, okay, square root of negative 8 is going to be 2 square root 2. I'll take care of the negative 1 underneath the radical by taking an I outside. So 2i square root 2 all over 6. This problem's got a lot in it because now I see that there's a 2 common to both terms in the numerator, and 2 also divides the denominator, so I can reduce this to lowest terms by factoring a 2 from the numerator. 2 times negative 1 plus or minus I square root 2. The denominator is 2 times 3, so I'll divide numerator and denominator by 2, divide out that 2, and hopefully this is the end of this problem. Negative 1 plus or minus I square root 2 all divided by 3. So there's my two solutions. This was the quickest method of solving this equation because it's not factorable. So I had to use the quadratic formula, and it's really very simple once you identify a, b, and c. If you've got that formula memorized, which I hope you do by this time, then substituting the numbers in. The rest is really just arithmetic. It's a little more complicated now because I have these complex numbers that I'm working with. But in any case, there's my two solutions, one when I use the addition sign and one when I use the subtraction sign.